This video is going to go over the math side of the mole and Avogadro's number. So we're going to talk about how to convert between the mole and particles. And you need a calculator handy, so make sure you have a calculator pulled up on your phone sitting next to you if you're at home, or you can find one on your laptop, or if you want to grab one from the front of the room, that's fine. Just make sure you Germ-X before and after. Okay, so in order to solve these problems, we are going to be using a 5-step problem-solving method because this will guarantee that you are walking through every single problem correctly. So when you are using this 5-step method, I know it can be a little bit tedious, but know that it is very, very effective, and future you will thank you for it, because even with some of these questions, you might be able to logically reason yourself through answering them. However, future you, when we get to like unit 5, is really going to thank current you because the math will get more complex. So make sure you follow along very carefully. And if you have questions, let me know, because this is going to be a foundational skill that we will build upon in the future. So let's get started. So every single time you write down a number, you are going to write down a number followed by a unit and some kind of stuff. And this is super duper important. Every single time you write down a number, it's going to be number, units, stuff. So let's go over this 5-step method. So step number 1 says, what are you given? So after you read the problem, you need to find what you're given. Step 2, what are you solving for? Figure out what the problem is asking you to do. And then number 3, what conversion factor or path do you need? For all of these problems, go ahead and tell you, you're going to have the same conversion factor because it's the only one you know. When we get later on, this is going to be more complicated. So for now, it's the same one, but we'll build on that skill later. Step number 4, you're going to set up dimensional analysis, and you probably don't know what that is yet unless you've already had physics. And basically, dimensional analysis is just a way for us to convert from one unit to another, or one, quote, dimension to another. And then number 5, complete the math and write the final answer with units and stuff. So I'm going to walk you through the first 2, B and C, completely, step by step. Pause the video where you need to, rewind and rewatch if you need to as well. I'll walk you through how to type this in the calculator as well. And then for D on your next page, you're going to start to do more of the problem on your own. So you're going to do like the first couple steps, and then we'll do the last few together. And then same thing for E. You'll do the first 2 or 3 steps. We'll do the last couple together. And then F and G, you're going to try those completely on your own. Okay, here we go. Your first problem says if there are 6.022 times 10 to the 23rd atoms of iron in an iron bar, how many moles is this iron bar? The reason I chose this one to start with is because it's the same as number 3 up here. So conceptually, you already know the answer is 1 mole of iron. And that's really helpful for starting out, that you understand what's happening conceptually. And we're starting off with an easy problem so you can pick up the pattern of how to solve these. I'm also going to try to color coordinate some things so you can see what is going where. So we're going to walk through our 5 steps. Step number 1, what are we given? So what are we given? We are given 6.022 times 10 to the 23rd atoms of iron. So all of that gets written down, and it's a lot to write down, but you do have to write all of that down. And instead of iron, the symbol for iron is Fe, so we're going to put Fe. We have a number, unit, and stuff. Step number 1 is done. Number 2, what are you solving for? It says how many moles, so we are looking for moles of iron. Number 3, what conversion factor or path do you need? Our conversion factor is going to come from up here where we labeled it conversion factor. So this is our conversion factor. 1 mole equals 6.022 times 10 to the 23rd particle. And we know that there are different types of particles. We are currently looking at the particle atoms. So our conversion factor for number 3 is 1 mole equals 6.022 times 10 to the 23rd atoms. because our problem is asking about atoms, and that is a type of particle. Number 4, this is the crazy step where we set up dimensional analysis. So follow along very, very closely. And even though you can answer this question without doing dimensional analysis, it is essential that you learn how to do this skill for later on in the semester. So the first thing you're going to do with dimensional analysis is you're going to draw a fraction bar. The next thing that's going to happen, you are going to take your given in number 1, and you're going to put that as the numerator. That will always be the same. Your given becomes your numerator. And you have to write all of it. So that's atoms of iron. The bottom of that first one will be 1. So always, 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 your first fraction that you set up, and you will always set up fractions for this anytime we're converting units like what we're doing right now, you're going to put your given, and you're going to put it over 1. The reason we put it over 1 is because of the identity property from math. And then you are going to multiply it by another fraction. And this is where things get a little complex, so watch carefully. Because we have atoms in the numerator right here, we have atoms right there, we have to put atoms down here. So up here and down here, your units are going to match. In order to figure out, though, what goes here in this second fraction, you're going to look at your conversion factor. So this conversion factor will end up right here. That is going to be your conversion factor. 1 mole compared to 6.022 times 10 to the 23rd atoms. So atoms is going to go on the bottom because that matches our unit up top. So we're going to put 6.022 times 10 to the 23rd atoms, and this will still be iron, so we're going to put Fe. And then you put the rest of whatever you have on the top. So we have 1 mole remaining in our conversion factor, so we're going to put 1 mole of iron on the top. The reason it's structured like this is because when we go to solve this problem, we really have one gigantic fraction. And we have a fraction that looks like this. So we know based upon math and what we have learned that if something in the numerators and the denominator matches, that it goes to 1. So this is the same as this, which means it cancels out and it turns into 1. So we have just canceled out a unit, and we are left with our unit to be moles Fe. And that's the beauty of dimensional analysis. We can cancel units. You'll notice for this, I went ahead and separated the fractions back out, and that is helpful for what we are about to do. So grab your calculator. Each fraction is going to go in parentheses, and then anytime you have scientific notation, we're going to nest those parentheses as well. So let's go ahead and start typing this in. So our first fraction, and we're just going from left to right, we have parenthesis, and then another parenthesis for our scientific notation. Close that first parenthesis. And then we're going to divide it by 1. So this is what we should have first. 6.022 times 10 to the 23rd divided by 1. The next thing that we read right there is a times sign. So we're going to hit multiply by. We're going to start our new fraction. 1 divided by, nest your parentheses, 6.022 times 10 to the 23rd. So this is what it should look like before you hit enter. So go ahead and hit enter. And you get 1. That is perfect. So to write down our answer, we need number, unit, stuff, number, unit, and stuff. So our final answer is 1 mole of iron. And that was a lot of work for one problem, I know. You will get faster as we go through these, but let's go ahead and talk about C. I'm gonna move the calculator for just a moment. And let's talk about C. We're going to use our same 5-step method, just like we did before. to solve it. So our first thing says, what are you given? And then we're gonna figure out what we're solving for number 2. So number 1, what are we given? While making a big batch of sweet tea, you pour 1.5 moles of sugar. So this is our given, 1.5 moles sugar. How many molecules of sugar did you add to your sweet tea? So number 2, we are looking for molecules of sugar. Number 3, our conversion factor is going to be the same for all of these. And the conversion factor we're using is Avogadro's number. So we have 1 mole equals 6.022 times 10 to the 23rd. And instead of particles, we're looking at a particular particle, and it is molecules. Okay, number 4, let's set up our dimensional analysis. So our first fraction, we're gonna take our given and put it over 1. So we've got 1.5 moles of sugar, and we put it over 1. Every single one of these will have your given over 1. Now we're going to multiply it so that we can cancel out moles of sugar. So we're going to multiply it. So our next fraction is going to come from our conversion factor. So this conversion factor will go here. The way that we order it depends on what is in this first fraction. So we have moles of sugar up here. Our units have to match diagonally. So moles of sugar will go down below. To figure out what number that is, we take a look at our conversion factor, and the number right there is 1, so we'll put 1. Now we're gonna put the rest of the conversion factor up top. So we've got 6.022 times 10 to the 23rd molecules of sugar. And we want to know what that equals. So let's check our setup though. Moles of sugar, that cancels. Setup looks really good. And let's talk about how to put this in our calculator. So same thing, we are going to put each of the fractions in parentheses. And anytime you see scientific notation, it gets extra parentheses. So we've got parentheses, 1.5 divided by 1 times, we'll nest those parentheses, and then divided by 1. So we have 1.5 divided by 1 times 6.022 times 10 to the 23rd divided by 1. And we get 9.033, and then we see this E right there, 23. What that means is times 10 to the 23rd. So that E means times 10 and your exponent. So our answer, and you can just go out a couple of decimal places. So we'll go 9.03 times 10 to the 23rd, and we still need units and stuff. So in order to get your units and stuff, whatever is up here, that becomes your units and stuff. So we have molecules of sugar. And that is our final answer. Go ahead and go to the next page. For this one, I want you to try to do steps 1, 2, and maybe 3 as well on your own. So step 1, figure out what you're given and write it down. Step 2, what are you looking for? Write it down. And step 3, what conversion factor you're gonna use. So go ahead and pause the video and test yourself to see how much you know. All right, let's check over what you found. So our given was 2.2 times 10 to the 23rd atoms of aluminum foil. Instead of writing aluminum foil every time, I'm gonna write Al because that is the symbol for aluminum on the periodic table. So we have 2.2 times 10 to the 23rd atoms, Al, number, units, stuff. Step 2, we're looking for how many moles of aluminum. So moles, Al. And our conversion factor is going to be the same one we've been using this whole time. 1 mole equals 6.022 times 10 to the 23rd, and this particle that we're using is atoms. So we've got atoms. And that's where you stopped working on your own. So let's pick up and finish this problem out together. So for number 4, we're going to set up dimensional analysis. So we'll write our first fraction, and we always put the given over 1. So we have 2.2 times 10 to the 23rd atoms AL over 1. So our given over 1. Next thing we're going to do is put our conversion factor so that our units cancel out. Atoms is currently my numerator, so I need atoms to be my next denominator. We have atoms over there, so this whole thing goes with atoms down here. 6.022 times 10 to the 23rd atoms, number, units, stuff, AL. And the remaining of that, 1 mole, becomes the numerator. 1 mole AL, number, units, stuff. So when we put this in our calculator, of course, we are going to nest our scientific notation. So our calculator is going to look like this. So you have 2.2 times 10 to the 23rd divided by 1 times 1 divided by 6.022 times 10 to the 23rd. And you get 0.365, blah, 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 blah. So let's go out just a couple decimal points. And number 5, our final answer will be 0.37 moles AL. Very good. For the next problem, try step 1, 2, 3, and go ahead and try step 4 on your own as well. Start testing to see what you know and what you don't and where you're getting stuck. Go ahead and pause the video and work on those steps now. Okay, let's go over what you worked on. Number 1, you found the given was 0.28 moles of lead, and instead of writing lead, I'm going to put the symbol PB because that's the symbol for lead on the periodic table. And number 2, we are looking for how many atoms of lead. Number 3, our conversion factor is still going to be the same one. We're relating moles to particles. 1 mole equals 6.022 times 10 to the 23rd atoms. And then hopefully you tried step 4 on your own. If you didn't try step 4 on your own, go ahead with this information and pause the video and try step 4 on your own. The answer for step 4 should look like this. You should have the given 0.28 moles of lead over 1. And then you notice that moles is on the numerator here, so it has to be on the denominator here. So when you choose from your conversion factor what goes where, you're going to put 1 mole on the bottom so that it matches diagonally. And then the rest of your conversion factor is going to go on the numerator, 6.022 times 10 to the 23rd atoms, we'll squeeze that in, of PB. Excellent. Grab a calculator and let's plug this in. When you plug it into your calculator, it should look like this, 0.28 divided by 1 times 6.022 times 10 to the 23rd, and those should be nested and divided by 1. So your final answer is 1.68 blah, blah, blah times 10 to the 23rd. So to write that down, let's just round to a couple decimal places. So we'll do 1.69 times 10 to the 23rd atoms of lead, PB. Okay, for the next 2 problems on here, pause the video and try the entire problem on your own, and then go back and check your work and see how you did. Okay, so for this one, your answer was 0.5 moles of Ag. Your given was 3.01 times 10 to the 23rd atoms. You were looking for moles, and your conversion factor is the same as it has been. You put your given over 1, and then you noticed you had atoms in the numerator, so atoms was now in the denominator. That's perfect, it cancels out. The rest of your conversion factor became your numerator. And if you look at the calculator on the right side, it should have looked like that. And 0.4998, we'll just round that to 0.5 moles Ag. And I used Ag because Ag is the symbol for silver on the periodic table. Okay, so for this last problem, we'll go over it. Hopefully you're feeling more proficient in these problems by now and you were able to get this one. Your answer is 1.81 times 10 to the 24th molecules of H2O, or water. So you were given 3 moles of water and you were looking for how many molecules of water. Same conversion factor, 1 mole equals 6.022 times 10 to the 23rd, and our particle this time is molecules. So you notice that your given was put over 1. And then your conversion factor was broken up so that it matched. So moles was on the bottom so that it crosses out diagonally, cancels out. And then molecules was on the top because that's what we were solving for. When you put that in your calculator, you can look over here on the right-hand side how it should look. 3 divided by 1 times 6.022 times 10 to the 23rd divided by 1, of course with our scientific notation nested. And that E24 means times 10 to the 24th. The last thing that you are going to do is you're going to flip the page, and I want you to answer this key question. This is a guiding question for our unit. It's one of our big questions, and this question is also going to be on your test. So there's plenty of room to write or draw a picture if you would also like to do that. The question is, are all moles the same? And then explain. And you can use an example or draw a picture to help you explain. So to help you think about this, think about a mole of sugar compared to a mole of salt, or a mole of pencils compared to a mole of basketballs. And explain, are all moles the same?